Hello everyone, myself Deepa, Mathematics Faculty of Silver Hills Public School. Today we will be dealing with the topic Quadratic Equations, Class 10 CBSE. Basically, this topic is divided into three parts. In the first part, we will be discussing what is a quadratic equation, where do we apply this quadratic equation in our day-to-day life. And in the second part, we will find different methods to solve a quadratic equation. And finally, in the third part, we will discuss the nature of roots of a quadratic equation. So, let us start. So, quadratic equation. Consider a polynomial p of x. A polynomial in one variable, say x. And we know polynomials can be classified into different types based on their degree. So, I am going to give examples for each polynomial. Let us take the first case. P of x is equal to say 2. What kind of a polynomial is this? This is called a constant polynomial. And what is the degree of this constant polynomial? You can always write 2 as 2 into x raised to 0. Isn't it? Now, what is the degree of this polynomial? We can see the power of the variable x is 0. So, we can conclude degree of a constant polynomial is 0. So, what is the standard form of representing a constant polynomial? I can always write a constant polynomial as p of x is equal to a. Now, what is this a? A is any real number other than 0. If a is 0, what happens? If a is 0, that polynomial is called, it's given another name, we call it as 0 polynomial, and its degree is not defined. But coming to constant polynomials, its degree is always defined and it is 0. Okay? Now, let us take another example. Say p of x is equal to 2x plus 3. Now, tell me children, what is the degree of this polynomial? Here the variable involved is x, and what is the power of x here? It is 1. So, I can say this is a polynomial of degree 1. And what do we call such polynomials? We call them as linear. So, what are linear polynomials? Polynomials whose degree is 1. And what is the general form of representing such polynomials? I can write it as, say, p of x is equal to sum ax plus b. What is this a and b? Where a comma b are real numbers. Okay, they are real numbers, and one condition is there, a not equal to 0. Why a not equal to 0? Suppose a is equal to 0. So, what happens? This ax completely goes and we will be left with just a single term, p of x is equal to b, and that is not a linear polynomial. And what is that? It is a constant polynomial. So, this condition a not equal to 0 is very, very important. So, polynomial of degree 0 of degree 1. Next, let us consider another polynomial whose degree is 2. Say x square, say x square plus x plus 1. Here the variable is x, and what is the highest power of the variable here? It is 2. And what is the name of such a polynomial? We know if a polynomial's degree is 2, we call it as a quadratic polynomial. And see children, our topic is quadratic equations, we are coming to it. So, any polynomial whose degree is 2 is called a quadratic polynomial. So, let us write the standard form of a quadratic polynomial. I can write the standard form of a quadratic polynomial as p of x is equal to ax square plus bx plus c. What are these a, b and c? They are constants where a, b, c are real numbers. And one condition is A not equal to 0. That is very important. The first constant can accept any real number value other than 0. So, we discuss constant polynomial, linear polynomial and quadratic polynomial. Now, if I equate this expression to 0, say, if I write ax square plus bx plus c is equal to 0, this is called a quadratic equation. That is, we are equating a quadratic polynomial to 0. Hope that's clear to all of you. So, let's analyze a situation where we apply quadratic equation in our day-to-day life. Let's give a name for our character. Say Ramu. Ramu wants to cover the floor of his house by a carpet completely. And then the floor's area is 120 square feet. Breadth is 2 feet less than the length. So, these are the ideas. The area of the floor is 120 square feet. Breadth is 2 feet less than the length. So, how will Ramu find the dimensions of the carpet? How can we help him without actually measuring the floor? Okay, that is our task. So, we will convert this situation into a mathematical problem. So, what all things we have here? This is Ramu's floor. It is rectangular in shape. We know the area of the floor. It is 120 square feet. This we'll take it as length and this is breadth. Okay. So, length is unknown. So, we'll name it as, say, some x. But we have some clue regarding the breadth. What's it? Breadth is 2 feet less than the length. So, it is x minus 2. And we all know if length and breadth is available, how do you calculate the area? Area is equal to length into breadth. That is equal to. So, what is the length here? It is x. So, we substitute here into. What is the breadth? X minus 2. X minus 2. Now, we open the brackets. This is equal to x square minus 2x. We also know the area is 120 square feet. So, I can equate this to 120. That is x square minus 2x equal to 120. So, we shift the constant to the left side. What do I get? X square minus 2x minus 120 is equal to 0. And what is this? This is a quadratic equation in its standard form. You have the variable x and the degree of x is 2. Now, when you solve this, we will get the value of x. And those methods we will be discussing. If we get the value of x, what is that corresponds to? This is our length L. And if L is available, how do we calculate the breadth? Breadth is, it's x minus 2. And which gives you the answer. Now, this carpet completely covers the floor. So, these are the dimensions of the floor. So, the dimensions of the carpet will be equal to the dimension of the floor. So, this is a situation where we apply quadratic equation in our day-to-day life. Now, let's discuss few questions to check whether the given equation is quadratic or not. So, let's go to the first question. We have an equation here. So I just want to check whether this is a quadratic equation or not. And we all know what is the general form or the standard form of a quadratic equation. The standard form is ax square plus bx plus c equal to 0, where a, b, c are real numbers, and one more condition, a not equal to 0. So here if we look like this, it is not in the standard form. So we will just simplify this. Now when we take the left side, x plus 1 whole square, we all know the expansion of that, it is x square plus 2x plus 1 equal to, on the right side I have x plus 2. Now what to do? We shift all the members to the left side. So I get x square plus 2x plus 1 minus x minus 2 is equal to 0. Now let us simplify this further. X square, now 2x minus x becomes plus x. You have plus 1 here, minus 2 there, minus 1 is equal to 0. Now look at this. The original question, the original equation is reduced to a standard form of a quadratic equation. So we can conclude this is a quadratic equation because the degree is 2 and it is in the standard form. So here what is the value of a? It is 1. What is the value of b? Meaning the coefficient of x, it is 1. And what is c? C is a constant term present here and it is minus 1. Now let us do one more example. Let us consider x plus 2 the whole square is equal to x into x plus 1. Again this is not in the standard form. Now let us see whether we can reduce into the standard form. Let us simplify the left side. It is of the form a plus b the whole square. So I can write it as x square plus 2ab. So 2 into x, which is 4x plus 4 equal to, now just open the bracket and see, we get x square plus x. Now we shift everything to the left side. So x square plus 4x plus 4 minus x square minus x equals 0. Now can we cancel something here? You have x square term minus x square is also there, it is getting cancelled. 4x and minus x becomes 3x. 3x plus 4 equal to 0. This is a simplified one. Now tell me whether this is a quadratic equation or not. It is not quadratic. Why? Because here the highest power of the variable is 1. So we conclude the second one is not a quadratic equation, but the first one is a quadratic equation. So by seeing this two, don't jump into conclusion that it's quadratic. We simplify and then let's conclude whether the given equation is quadratic or not. Now let's discuss roots of a quadratic equation. So what do you mean by root of a quadratic equation? So let's write the standard form of a quadratic equation first of all. So what's the standard form? Ax square plus bx plus c is equal to 0. This is the standard form of a quadratic equation. Any real number alpha, okay, any real number alpha satisfying this equation is said to be a root of a quadratic equation. Meaning, if alpha is a root of a quadratic equation, a alpha square plus b alpha plus c is equal to 0. If beta is a root, what will be the condition? A beta square plus b beta plus c equal to 0. So now we will be discussing the different methods of finding the roots of a quadratic equation. So we will just discuss first method is method of factorization. factorization method. So what do you mean by factorization of a polynomial? Splitting a polynomial or breaking a polynomial into linear factors is called factorization. And last year you have learned how to factorize a quadratic polynomial. We can use factor theorem. We can also use splitting the middle term. So we will be using splitting the middle term method here to find the roots of a quadratic equation. So now we will go to an example. Consider x square plus 5x plus 4 is equal to 0. This is a quadratic equation. Variable is x. Now we are going to find the roots of this quadratic equation. So what we do is, let's name this part as p of x. So let p of x is equal to x square plus 5x plus 4. So this is my polynomial, that is quadratic polynomial. And now I am going to split the middle term of this quadratic polynomial. Here sum is equal to 5, product is equal to 4, meaning I need to select two numbers whose sum is 5. And from where did I get this 5? This we used in the splitting the middle term. This 5 is actually the coefficient of x. So I need two numbers whose sum is the coefficient of x, and that is 5. And product is the constant into the coefficient of x square. So the constant present here is 4. 4 into 1 gives you 4. So how can you select two numbers whose product is 4 and sum is 5? So think like that. We know 2 into 2 is 4, fine. But 2 plus 2 does not give the answer 5. So we will have to select some other number. So let's take, say, 1 into 4. 1 and 4. 1 into 4 gives you the answer 4. 1 plus 4 gives you the answer 5. So we are going to split this 5x using 1 and 4. Let's see. This can be written as x square. Now 5x I can write it as x plus 4x plus 4, because already we selected the numbers 1 and 4. So we can read it as x 4x, which when combined gives you 5x. Now what to do? We combine the first two terms, the last two terms. So when you combine the first two terms, what is the common thing there? I can take x outside and then I get x plus 1. When you combine the next two terms, what is a common thing? I can take 4 outside, and what remains inside the bracket? It is x plus 1. Now what is common in both the terms? It is x plus 1. So we will just take it outside. X plus 1 taken out, and then inside the bracket what comes? Here x plus 1 is gone out. So x remains plus. From here x plus 1 is gone, so 4 remains. That means you have factorized, you have broken this quadratic into the product of linear factors. And this method is called splitting the middle term method. Now we need to find the roots of this equation. So I am just equating. P of x equal to 0. What does that mean? This is our P of x. That is x plus 1 into x plus 4 equal to 0. product of two things equals 0. So I can write x plus 1 equal to 0 or x plus 4 equal to 0. What does that mean? X is equal to minus 1 or x is equal to minus 4. So how many roots or how many values of x are there? You have minus 1 and minus 4. So that's how we find the roots of a quadratic polynomial. By which method? By method of factorization. So nothing much, we just factorize the left hand side, that is a quadratic polynomial using splitting the middle term. And splitting the middle term means we just select two numbers whose sum is the coefficient of x. So here it's 5 and product is the product of constant term and the coefficient of x square. So I get 1 into 4, that is 4. Accordingly, we'll select the numbers and then we'll split the middle term 5x. After that, we equate the polynomial to 0. We collect the values of x and those values are called roots of the quadratic equation. So how many roots are there? There are two roots here, minus 1 and minus 4. And then whenever the degree of a polynomial is 2, its roots will not exceed 2. Maximum 2 roots will be there. Okay, we will say at most 2 roots, less than or equal to 2 roots. It won't go beyond that. Hope this example is clear to all of you. Now we will move to the next question. The same factorization method we are applying there. So 5x square minus 13x minus 6 is equal to 0. So now we are going to find the roots of this quadratic equation. Okay, so let's consider p of x. Let p of x is equal to 5x square minus 13x minus 6. That is, we are just considering the polynomial itself. Now split the middle terms, will factorize this expression. So to split the middle term, we need two numbers. We need to select two numbers whose sum is the coefficient of x. So what can we write here? Sum is equal to, the coefficient of x is minus 13. So we'll write minus 13. And what is a product? So product equals the constant term into the coefficient of x square. So it's minus 6 into 5, which gives you minus 30. So which are those two numbers satisfying these two conditions? So let's check the product. Product is minus 30. So which all numbers when you multiply gives you 30? Think like that. So we know 5 into 6 is 30, fine. But then it doesn't match here. We can't find the sum 13. Then what is the next method? I can select two numbers 15 and 2. And we know 15 into 2 is 30. But then there is a minus sign here. And sum is also minus 13. It has a minus symbol. So how can we give a sign? If I give minus to 15, minus 15 into 2 gives you minus 30. Minus 15 plus 2 gives you minus 13. That means our selection is right. So what are the numbers? The numbers are minus 15 and 2. Now let's split minus 13x using minus 15 and 2. So this can be written as 5x square minus 15x plus 2x minus 6. Okay? This is equal to, combine the first two terms, last two terms. What is common in these two? It's 5x. Inside the bracket you have x minus 3. When you combine these two, what is common there? You have just 2 common which you took outside, and inside the bracket remains x minus 3. Now what is common in both the terms? It's x minus 3. Take it outside. This is equal to x minus 3 and inside bracket you have 5x, because 5x is remaining here, so I took it here, plus x minus 3 is already taken outside, so you have 2. So my p of x is ready. I've broken this quadratic polynomial as a product of two linear terms. Now we are going to solve it. I need to find the value of x. We are solving a quadratic equation. So p of x equal to 0. What does that mean? Means x minus 3 into 5x plus 2 is equal to 0. This shows x minus 3 is 0 or 5x plus 2 is equal to 0. X minus 3 equal to 0 means what is the value of x? X is equal to 3. Just shift minus 3 to the other side. Or 5x plus 2 equal to 0 means 5x is equal to minus 2 or x is equal to minus 2 by 5. So how many roots did we get here? We got 2 roots. One is 3 and the other one is minus 2 by 5. So we will do 2 more questions. Question number 3. Root 2x square plus 7x plus 5 root 2 is equal to 0. Solve root 2x square plus 7x plus 5 root 2 is equal to 0. So here root is coming, but still method is same. We follow the splitting the middle term method. We equate it to 0 and we collect the values of x. So let's take the left side expression. We'll name it as p of x. So let p of x is equal to root of x square plus 7x plus 5 root 2. I want two numbers whose sum is 7. So sum equals 7 and product is equal to, what will be the product? It's a product of the constant term and the coefficient of x square. So as a constant term we have 5 root 2. So 5 root 2 into root 2. And what is 5 root 2 into root 2? It is 5 root 2 into root 2 is 10, because root 2 into root 2 is 2, 2 into 5 is 10. So we have sum equals 7, product is equal to 10. So how can you select those two numbers? We know 2 into 5 is 10, yes, 2 into 5 is 10, 2 plus 5 is 7. So our numbers are ready. Now it's just a matter of splitting the middle term. So this p of x can be written as root 2x square. 7x I can write as 2x plus 5x plus 2x plus 5x plus 5 root 2. Now combine the first two terms, take the common things outside. Combine the next two terms, take the common things outside. Now this is equal to, what is common in those two terms? So when we look, x is common, fine. Is there anything else common here? 2 can be written as root 2 into root 2, because root 2 into root 2 is 2. So I am going to take root 2x outside. So if I take root 2x outside, here x remains, and what remains here? Plus root 2 remains. Now just open the bracket and see if you have any doubt. Root 2x into x is root 2x square. Root 2x into root 2 is 2x plus From here I can take 5 outside. 5 into, in brackets comes x plus root 2. In these two terms, x plus root 2 is common. We just take it outside. So, x plus root 2 in a bracket, and inside another bracket I have root 2x plus 5. Okay. So, the left side we simplified. Now, let us equate this to 0. P of x equal to 0 means x plus root 2 into root 2x plus 5 equal to 0. Product of two things equal to 0. So, I can write this equal to 0 or the second term equal to 0. X plus root 2 equal to 0 or root 2x plus 5 equal to 0. X plus root 2 equal to 0 means x is equal to minus root 2, or here, from here, if I shift 5 to the other side, I get root 2x is equal to minus 5, x is equal to minus 5 by root 2. So, our values are ready or our roots are ready. What are the roots? One is minus root 2 and the other one is minus 5 by root 2. Now, let us solve one more question from this part, that is method of factorization. So, question number 4. Factorize 2x square minus x plus 1 by 8 is equal to 0. 2x square minus x plus 1 by 8 is equal to 0. So, you have a fraction coming there as a constant term, but method is same. What we can do is we just we'll just multiply with 8 throughout and then convert this original question. We can write it as, say, 1 by 8 into 16x square minus 8x plus 1 is equal to 0. I can modify this question. Now, this 1 by 8 anyway that can't be 0. So, what is the only possible condition? 16x square minus 8x plus 1 equal to 0. So, in the next step I can write 16x square minus 8x plus 1 is equal to 0. So, we modified the question. Now, we are going to solve this. We are going to split the middle term of the left side expression. We equate that to 0 and we collect the values of x. So, let P of x is equal to 16x square minus 8x plus 1. I need two numbers whose sum is equal to, what will be the sum? What's the coefficient of x here? Minus 8. Sum is minus 8. And what's the product? Product is equal to the constant term into the coefficient of x square. So, here the constant term is 1, 1 into 16, that's equal to 16. So, think, what are those two numbers whose product is 16 and sum equals minus 8. So, 2 into 8 is equal to 16. But then 2 plus 8 or minus 2 plus 8, nothing gives you the answer minus 8. So, we will have to select some other combination. So, why don't we select 4 and 4? We know 4 into 4 is 16. 4 plus 4 is 8. But then I need minus 8. So, what to do? Just change the sign. Minus 4 into minus 4 gives you 16. Minus 4 plus minus 4 is minus 8. So, our selection is ready. Now, we will modify the question. 16x square minus 8x can be written as minus 4x plus 1. As we did before, combine the first two terms, the next two terms. So, if you combine the first 2. What is common in both the terms? This is equal to x is common. What else is common? 4 is also common there. So, I took 4x outside. 4x minus 1. And then in the next term also I must get a term inside a bracket so that it will be common. Here already I have 4x minus 1. So, think, how can you introduce 4x minus 1 there? When you take 4x and 1, nothing is common. So, what we do is, I just take a minus symbol outside. So, what happens? It's minus 4x. Minus is taken outside. So, it becomes just 4x. It's plus here. A minus is taken outside. So, I would write minus 1. If any confusion is there, just open the bracket. Minus into 4x is minus 4x. Minus 1 into minus 1, it is plus 1. So, there is no, we did not make any mistake, it is right. Now, from these two terms, what is common? 4x minus 1 is common. Let us take it outside. So, 4x minus 1 taken out. And what remains? 4x minus 1 is gone. 4x comes minus 1. We simplified or we factorized p of x. Now, we are going to solve it. P of x equal to 0 means, this is our p of x, 4x minus 1 into 4x minus 1 equal to 0. 4x minus 1 equal to 0 or 4x minus 1 equal to 0. From here I get x is equal to 1 by 4 because 1 goes to the other side, x is 1 by 4. Or what do you get here? Same thing, I get x is equal to 1 by 4. So, you are getting two equal roots and that is 1 by 4. Not two different roots, here the values of x, it is same and we got it as 1 by 4. So, this is the first method, factorization. So, we have another method, that is using the formula, quadratic formula. So, which we will be discussing in the next session. So, this is enough for today. Thank you.